Hi everyone, the purpose of this video is going to be looking at the fasting state. So when we look at the fasting state, we're going to assume that our blood sugars are very low. So here, if this is our normal, we're going to have low blood sugar. So it's underneath the normal kind of level here, which is the dotted line. And it's important to note that the hormone that's driving this is glucagon. So glucagon is that hormone that's going to be responsible for the different metabolic pathways. When the body is first low for sugar, we're going to go to glycogen. So this is going to be glycogenolysis. And in glycogenolysis, we're simply going to be breaking down glycogen for energy. Now, there's two different roles that are going to happen. So if we look at the liver first, so here's our liver. The glycogen here is going to be able to provide the blood sugar increase. So glycogen breaks down to glucose. And then glucose can go out into that bloodstream. So if this is our bloodstream, so blood, then that glucose can travel throughout the body. Now, skeletal muscle is the second place where we store glycogen. So this is going to be our skeletal muscle. And something that's different here is that the glycogen is basically trapped inside. So that glycogen is going to break down to what we call glucose 6 and then provide ATP right there locally. So again, it's only able to work on that actual muscle. Now, if you recall, glycogen is limited. So once we have no more glycogen, then we are going to basically say our body still needs energy. Where are we going to go next? So we're going to actually start breaking down fat. So that is called beta oxidation. And beta oxidation is simply the breakdown of lipids for energy. Now, remember that this is a very unique step here because when we're inside the cell, so if this is the cell, what happens is we need to get it into that mitochondria. And because it's so large, because fatty acid is so large, we need some help. So the fatty acid is actually going to get on the school bus, is what I referred to it in class, also known as the carnitine shuttle. This carnitine shuttle, again, you should note that it requires pantothenic acid, which is just vitamin B5. So at this point, the fatty acid is able to travel inside of that mitochondria because the carnitine shuttle is going to drop it off. I used the analogy earlier in a video. From that fatty acid, it's going to convert to acetyl-CoA. Acetyl-CoA is going to go through that Krebs cycle. And then it's going to go to the electron transport chain, which ultimately produces that ATP. And this is when we get that energy. Now, this is going to continue to break down. And the last step here is going to be proteolysis. So proteolysis is simply the breakdown of protein. Now, one thing to note here is this is really that final step. When we look at protein, we can break it down into two different pathways. The first one is going to be the carbon skeleton, which can provide some ATP through, basically this is going to be that gluconeogenesis. So gluconeogenesis is simply making glucose from non-carbohydrate sources. So we can look at lactic acid as an example. In this case, it would be the glycerol backbone from triglycerides, or even some highly functioning amino acids are able to give a little bit of energy, but it's really not that economical. And then the other piece of the protein is your amino group, and that amino group, if you recall, is going to be toxic, so it turns to urea, and then it's excreted throughout the body. Now, when we're breaking down this much protein, that's really the last step in the fasting state, and it can only happen for so long, and the body is going to shut down from starvation.